Mary.
Thank you, Carol, and thank you for everybody for joining this afternoon or evening, I guess, depending on what time zone you're in. As Carol mentioned, today we're going to be talking about triage collection and timeline analysis with Kabe. Just to give you a quick intro about myself, I'm a Senior VP with Kroll Cyber Risk, where we do network intrusion cases, DFIR cases, IP theft, all sorts of things. And my background is mainly in host-based forensics. You can reach me at Twitter at Mary DeGrazia, and I also have my blog spot. And as a side note, my first job was working at Dairy Queen, serving up blizzards and banana splits. One of the benefits of working with Kroll is that I get to work from home, but that also means that my little dog might decide to chime in during the presentation. So I apologize in advance if that happens. So I am super excited to be talking to you about the topic today, which is a timeline analysis by utilizing Kabe. So there are kind of four areas that I'm going to be highlighting or going over today, and that's going to be the triage collection, or the collection of a core set of files from a Windows system, and then utilizing Kabe to create mini timelines, and then finally diving into how to analyze and how to utilize those timelines. So if you're not familiar with Kabe, Kabe is a tool written by Eric Zimmerman, who is also a SANS instructor. I am not going to be doing a deep dive into Kabe, but I will be going over some of the basics of Kabe to show how it works and how to leverage it to do timelining. So the approach we're taking today is what is called a triage approach. And with the triage approach, we're going to focus really on a core set of files. So rather than analyze a whole disk image or take a disk image, which could span, 3 or 4 hours to take the disk image, then you pop it into your forensic tool, you start kicking off your processes, you could be looking, at maybe 5 hours before you actually start conducting any type of analysis. So with the triage approach, we're going to focus on some core files, which will mean our data set will be reduced greatly. So instead of 300 gigs of data to go through, a terabyte of data to go through, you're talking really about a handful of systems, maybe 200 or 300 megs, maybe a gig at the most if you've got a system that is heavily utilized. And this is really where the beauty of Kabe comes in. When we talk about the triage data, and for this presentation and this walkthrough, I'm going to be focusing on 3 data sets. The 3 data sets will be the file system. Of course, with the file system, we'll be talking about files that have been created, and along with that, any timestamps associated with it on the system: modified, access, born, record, update. The next data set will be the registry hives. The registry hives contain a wealth of information in them. When you think about Windows and you think about how you interact with it and how you use Windows, all the settings it remembers, you log into your computer and it will bring up maybe the browser you're working on, the last tabs. You'll have Windows Explorer windows all around, it'll remember the last documents that you worked on. All of this information is tracked in the registry. So when we talk about user activity and things that happen on the system, the registry files are going to really give us a lot of information. The other data set will be the Windows event logs. So when we talk about attackers coming into the environment and moving around laterally, we have the terminal services event logs that will track that information. The security event logs, which will also track logins. We have USB device activity that's occurring in the event logs, system and application events. So when you're conducting your analysis and you think about how you're conducting analysis, a lot of it focuses around these core data sets. So by leveraging triage collection, before we even start taking an image of a system, we can collect these files and begin processing them really within a matter of minutes or maybe an hour or so. And you can really start diving in and start doing analysis without waiting and waiting for everything else to kick off. The other advantage of this, of course, is that you have smaller data sets to deal with. So if you need to share files or analysis with other examiners, it's relatively easy to do because of the file size. All right, so now I'm going to dive into some Kabe basics. Kabe, as I mentioned before, is a tool that was written by Eric Zimmerman, and this is Eric's words, not mine. Kabe by itself is dumb. Kabe is basically a framework that lets you call what are called targets and modules to both collect and process data. So with the targets, you tell Kabe the type of files that you would like to collect. So this could be the MFT for the file system. You can designate which registry hives you'd like to collect, the NT users, the system, the SAM, the event logs, and maybe you're working a case where you have a specific artifact that you need collected across the environment. Well, you can leverage the target modules to do this. The next one are the modules, and the modules tell Kabe, okay, what do I want to do with this data now? Now that I've collected it, how am I going to process it? So for instance, if you're collecting the AM cache or an NT user, you would then tell Kabe through these modules, I want to run this program against this target or this file to generate outputs. Now this can all be done on a mounted image or a live system. So it makes Kabe highly versatile. So I'm just going to show real quickly, if you're not familiar with Kabe, what Kabe looks like and how it operates. So here's the latest version of Kabe. And on the left-hand side is where I have my target options. And you can see there are already a lot of targets included, if you will, in the installation of Kabe. Now, one of the great things about Kabe is that people within the community can collaborate on GitHub and submit their own targets and their own modules, which is exactly what I've done for the timeline analysis. So if we take a look at some of these, here's one for the AM cache hive. If you want to know exactly what a target is collecting, you can just double click on it and it will bring up an editor and it'll show you exactly what files it's collecting. Here is one that's just a basic collection. So in the basic collection, you can see there's a variety of things here. Here we have the AM cache. Now the interesting thing about the targets is a target file can call another target file. So you can group what you need to collect and then kind of use a master target file to call those. A great example of that would be something like the event logs. So in this basic collection, you're specifying collect the event logs, collect the registry files, and some additional information. So here, if I wanted to know, okay, well, that's great, it's collecting this, but I want to know exactly which NTUser.dat files are being collected by this kind of parent script. You can go down, and here's kind of the nice thing about Kabe 2. Eric's put in a lot of great features. I can go in and select the registry hives, and then I can see, okay, exactly which ones it's collecting. Now here, we kind of got a nested situation. It's showing registry hive system and registry hive users. So once again, I can kind of click into those and see, okay, for the users, we have the NTUser.dat, we have the transaction logs, all of this information. On the right-hand side, we have the modules. And the modules will specify, okay, once I've collected this data on the left-hand side, how am I going to process it? What am I going to do with it? So if we collect the AM cache hive, we would want to probably use an AM cache parser to go through that. And so the module tells Kabe what executable to run and where that will go. Now, Eric Zimmerman has done a great job writing documentation on how to write the target and the modules. In fact, he's included a little link down here where you can click on it, and that will take you directly to the documentation for Kabe. It walks through how to write the targets, how to write the modules, but honestly, it's really easy to go in and just modify an existing one, and we'll talk about that a little bit later. So that's kind of the breakdown on the basics of Kabe. Right here, when you do the target collection, you're going to specify the source. So the source can be, if you're running it from an external USB drive, you would select the C drive of the system that you're doing the collection from, and then your destination would point to the external drive. If it's a mounted image, you would mount the image and of course point it to the mounted letter. And then the module source, and we'll run through this a bit later when I do the timeline so you can see an example of this working. The module source will be where the data is dumped out from and where you need to collect it from. So before I move on, I just want to take a pause and ask if anybody has any questions kind of around the basics of Kabe, how Kabe works, and how you do collection with it. As I mentioned, I'm not going to dive too much into it, but just kind of showing you initially how to get familiar with it and use it.
All right, Mary, we do have one question. Someone asks, is Kabe a free tool? And we did get another one in after that. Go ahead with the first.
Yes, Kabe is a free tool. I'll be providing a link at the end of the presentation where you can download it, or of course you can probably Google Kabe forensic tool and pull it up. It is a free tool. I do believe you have to put in your email address to be able to download it, but it is free. And the modules are all open source and hosted on GitHub.
All right, thank you. Someone asks kind of several questions in a row. Can it be automated? Is it command line based, as in running in a script?
Yes. So yes to both of those questions. As you can see the screenshot below, there are two interfaces to Kabe. Kabe runs as a GUI, and there's also a command line version of Kabe. Now, what's really cool about it is there are actually a lot of switches that can be used with Kabe. And to be honest, for me, it was a little bit overwhelming. But what's really cool is that you can launch the GUI interface, and as you build out your targets and your modules, it will build out this command line for you. So what you can do is if you have, let's say, 3 or 4 images mounted, you could write a batch script that then calls Kabe and runs through Kabe using the command line. All of the tools used within the modules within Kabe need to be command line, because what Kabe does is use command line parameters to call those tools as well. So yes, it can be automated. It is command line, and it's also GUI.
All right, thanks. We've had a bunch more questions come in. Let's see. Is it free for consulting use?
Yes.
Okay. This one I'm not sure you want to answer, so feel free to pass on this and someone can reach out directly. How does Kabe compare to F-response or autopsy?
Or autopsy. So I didn't catch, so I think you said autopsy and F-response.
Yes.
I'm actually, I've used autopsy as far as the GUI, and autopsy, if you're talking about the GUI, that's more where you're loading in an image, you're running keyword searches. This is more something where you're choosing artifacts to look at and then specific processes to run over them. F-response I haven't used a lot, but my understanding of F-response is that you can connect in remotely and do things remotely with F-response. Now, I do believe Eric Zimmerman's adding some SFTP capabilities with Kabe, but it's a little bit different. So you can definitely use those tools and use Kabe to kind of augment what else you're doing. So,
all right. So Mary, you're so successful with this Q&A. We've got 10 more questions. I'm not sure if you want me to continue.
Yes, let's hold on, and so I can make sure I get through the material. I'll take another pause again through the next section, and then we can revisit some of those questions if they're not answered in the rest of the presentation.
All right, so those of you who have submitted questions, Send me another message if you feel like your question was already answered, and then I won't be repetitive there. All right, go ahead, Mary. I'll go on mute.
Okay, great. So I have written a target for collection that will do or will collect the files that I mentioned earlier, for the mini timeline. And for that, that is going to be the event logs, the file system, and the registry hives. And when we talk about the registry hives, that's going to be security, SAM, system, NT user, user class, those type of things. Event logs will be both EVT and EVTX, depending on the operating system, and the file system will be the MFT. So I'm just going to run through here quickly how to do that. So for my target source, I'm actually going to use Arsenal Image Mounter to mount my image that I have. Arsenal Image Mounter is a free tool. They do have a pro version as well that you can buy. And one of the benefits to Arsenal Image Mounter is that it will give you access to the volume shadow copies. As part of this process, I am not going through the volume shadow copies, but I think that's an important differentiator when it comes to this versus some of the other tools out there to mount things like FTK. So Eric Zimmerman recommends using this with his tool in the event that you want to process volume shadow copies. So I have a forensic image that I mounted, and the main partition, as you can see here, was mounted as the F drive. You know, I've got my windows, my users. You can see there's a handful of users here, so everything looks good. My target source now, I'm just going to pick the F drive, and then my target destination, this is going to be where my outputs are going to go. So I'm just going to make it a short path, and so this is kind of funny. Eric, sometimes he does some troubleshooting and bug shooting, and I'll do it with him, and he was getting mad at me because I was using really long file paths. So he recommends using short file paths, so I'm following that convention here. I just put it right at the root of my C drive, triage collection. And then I'm just going to select this to run, okay? So target source, destination, the mini timeline collection, which is the MFT registry event logs to generate a mini timeline. If you want to, you can put this in a zip file, a VHD, a VHDX, bunch of different options here. I'm not really going to cover all of those today. And right here, you can see it's built out my command line. So if I wanted to run this through the command line, I could do it there. And I'm going to go ahead and execute it. Right now, it's giving me a warning that I have flush enabled. Basically, if you're working multiple systems, multiple cases, you want to make sure that you're not commingling data. So this flush option will keep you from doing that. It's going to go ahead and delete everything that's and dump everything too. I'm just going to click OK because that's fine. And right here, it's running through. And as you can see, that happened pretty quickly. It took about 2 seconds to collect all of that data. So if you're thinking the field or whatever, you can potentially attach a drive to a write blocker, grab the triage data first using Kabe, and then you can take off your image and begin analyzing the data. So I'm going to press any key to exit and show you what the outputs look like. So right here is where it dumped it, triage collection. And F, so it just gave it the same drive letter. It's got a log file, a bunch of information here. And here you can see this is where it dumped out my information, my MFT, my Windows System 32 config. I also have Win event for all my event logs. Boom, done. So that information's been collected, and now I can continue on and talk more about timelining and what we're going to do with the data once we have collected it. Okay, so let's talk about timelining. Someone mentioned Autopsy earlier, great open source tool to go through and work with images. Here, I've got a screenshot of X-Way. So when you think about your analysis and your processes and what you're doing, we have so many different artifacts out there. Here, you know, I've looked at the X-Way, so maybe I'm looking for suspicious files created around a certain time. So I might sort by the modified date, look for something within my time range and find an interesting file. Okay, so maybe I find an interesting file has been created. I'm like, okay, I want to go see maybe if there's a run key associated with that. So then I might open up Registry Explorer and go look at that run key and go see what keys may have been modified around that time. And as I'm looking and working with all this data, it's presented by these programs in different ways. So if I'm building out a timeline or building out an Excel sheet that I'm going to share with a client that kind of tells the story, you know, I'm going to be in these programs, copy, right click, paste, put it in. You know, I've got another field for description. Maybe I type something in. Maybe I copy and paste the key. You kind of just end up futzing around with all of this data. Here's another example. I'm using RegRipper. Maybe I want to go see if there was a suspicious service that was installed. So I run RegRipper, and here you can see the timestamps are different. You know, they're in month-day format, but it's kind of the shorthand format. So now if I've got an Excel sheet with these timestamps, I've got to go in and type in 8/11/2019, copy paste. So you can kind of see how working with all of this data and trying to consolidate it all into one format to be shared with a client can be frustrating, or even for your notes. And here's an example, an event log with a suspicious entry in it with some PowerShell code. So now, you know, I might go like, okay, I've got this suspicious event log entry. Let me go back to Registry Explorer and see what's going on. And now let me go back into X-rays and see what's going on. And timelining into one consolidated format can really help make connections clear, because you can see things in there that you may not know that you should be going to look at, or that you may not be quite familiar with. So the benefit of having a timeline is that you're going to be able to combine multiple artifacts into basically one spreadsheet, all into one standardized format. And through this process, you're going to normalize all these timestamps. So a lot of these utilities might take something that is presented in a local time format and put it into UTC, which is a format that we use in forensics a lot, so that we make sure when we're looking at timestamps, they're the same across multiple systems, or they're the same across multiple artifacts. And like I mentioned before, it really helps go with the reporting. Because now you have a consolidated timeline that you can put into report, human readable, and it's understandable to really help build out this picture. So my personal timeline format is the TLN format. This was first pushed out by Harlan Carvey and discussed by Harlan Carvey years ago, like 10 years ago, back in 2009. And I like it because it's nice, simple, and concise, and I can fit it all into, you know, a Word document, right? It's not 35 columns of data stretching across. It's going to break up and print and just be funky and not work well. So this TLN format has the time, which is a 32-bit Unix or epoch timestamp, the source that it came from. So that would be your event log, your registry, your file, maybe it's firewall logs. It doesn't have to be just the 3 artifacts that we're kind of pulling and discussing today. It's whatever's going to make sense for your case. You know, maybe it's NetFlow data, those type of things. There has to be a host, or, you know, where this data came from. So that's the computer name, IP address, once again, whatever is going to make sense for your particular data source. The next thing is the user. So if there is a user that is able to be tied back to that data. So when we talk about the registry hives, opening at documents, jump lists, internet history, all of those things can be tied back to users. So if that's possible, we're going to have that user field populated with the user. And then last but not least, and probably the meat of the entry, is going to be the description. So if we're talking about event logs, that's going to be the event ID along with a description of what that event log is, you know, a remote connection, a login, maybe it's an AV alert. When we talk about the registry, it's going to be the registry key, and in some instances, maybe the registry key and the value, depending on the tool that you use. I really recommend going through and reading Harlan's post on this TLN format. He actually runs through and steps through a lot of the things that we're going to be leveraging Kabe to kind of do and to automate this process. And I just wanted to share with you an example of where we are going with this and what we are going to accomplish at the end of this after we get done running Kabe. Now, I know my presentation is an hour, but as you're going to see, when you run Kabe, it just took a matter of seconds to collect the data, and it's just going to take a matter, in my particular example, I've got a small image to work with, so it's just going to take a matter of seconds to generate this timeline. In your case, the system might be a little bit longer, so it might take a little bit longer, but in practice, I've found that it can take anywhere from maybe 5 to 20 minutes on a system, and for your bigger systems, it might be an hour to churn through, but really it happens pretty quickly. So as you can see in this timeline, we have registry, we have file, we have event logs, and when you start putting all of this data sequentially next to each other, as an examiner and an analyst, you can really begin to put together connections, because now when you look at that registry key and you see that, you know, the user assist was located or executed notepad, now you can see within the same proximity, you have an account that was logged off. So now you have an idea of what type of login it was, what account was associated with it, and then because the file system is also there, I also have a prefetch file that indicates that notepad was ran. So right with a timeline, and you begin to get your pivot points, you can really start to make these connections about other events that happen in close proximity. So if you have malware that's installed on a system and you find the file on the system, now you can go into that timeline when that malware was created, and you can see, were there any persistent mechanisms that happened? Did it change any firewall rules? Did it drop any other files? And you have all of this information right in front of you within the timeline, which I think is really exciting. There are several tools that I'm aware of, and I'm sure there are more out there, even more out there in the community that support this TLN format. Of course, Harlan Carvey's Reg Ripper and a lot of the tools he developed, he outputs into TLN format. There's also Plazio, which is the new version of the log to timeline. So if you like working with Plazio, you can leverage Plazio using framework to call your favorite parsers out and automate that process. There is also TZWorks, which has a great suite of tools that process different artifacts, and they also output in TLN format. So any of the tools that you're using that output into TLN format can be leveraged to build upon and to create the timeline I just showed in the previous slide. So I modules that will parse various artifacts and put them into the TLN format. Now, really, I have to give shout outs to everybody that have created these tools. I'm just writing the modules. I'm piggybacking off of their excellent work that they've done out there in the community. And all these tools that I'm sharing are free. Some of them are open source, some of them might be closed source, but they're still free to use. So for the file system, I'm calling MFTE command written by Eric Zimmerman. His file will parse the MFT, and if you're not familiar with the MFT, it's basically a file system listing a directory, if you will, of everything that's on the system. So we're going to get, you know, the modified, active, created, born dates of files on the system. Now, Eric Zimmerman's tool outputs into a bunch of different formats. One of them is the body file format. Since it's not TLN format, I'm actually going to use a tool by Harlan Carvey called body file to parse out that body file into the TLN format. There is another tool out there called FLS, which is part of the sleuth kit, which will give you directory listing. Great tool. It's not as fast as MFT, but it also is a little bit more thorough. It's going to go through and get your $i index files, which will give you a little bit more visibility, but it does take a little bit longer to run. So that could potentially be something somebody else there could write as a module with FLS, because it also outputs into the body file format. To get that data that's inside the registry, I'll be using two tools by Harlan Carvey. One is Reg Time. What Reg Time will do is it will go through each of the registry hives and pull out the last modified / last written date of every single registry key within the Hive, which is glorious. That is what is going to let us see those run keys, MRUs, information like that that may happen while there's other activity going on that we're interested in. The second tool of his that I'm using is RegRipper. A lot of people use the GUI interface of RegRipper, but there's actually a command line version called rip.exe. Rip.exe lets you call individual plugins that Harlan has written that will target key artifacts within the registry, and they output into timeline format, which I think is really cool. I'll just pop in here real quick and show you. So within the Kabe directory, as I was speaking before, there's modules and targets. And within the modules is a bin directory. And the bin directory is basically going to contain any of the executables that will be called. So right here is RegRipper, and here's the plugins folder. And as you can see, there are tons of plugins that have been written that target different things in here. CC Cleaner, just a bunch of fun things, auto runs. So if I just put in TLN and take a look at how many plugins in here are supporting that TLN output. I mean, there's the MUI cache, LogMeIn, Landesk, which has a ton of information, SAMParse, Shimcache. I mean, Harlan has spent a lot of time putting these TLN plugins out there, and these can all be leveraged to build out that timeline, which is just absolutely fantastic. The next tool I'll be using, two of them, to go through the event logs is EVT Parse, once again by Harlan Kabe, to go through the EVTX format for event logs, and then EVTXE command by Eric Zimmerman. This one will parse out the EVTX files. Now, Eric Zimmerman's tool outputs into a CSV format. So I just wrote a little utility that will go through and convert that CSV format into the TLN. So if you have any command line tools out there, or even GUI tools that you use that output into this format, you can easily write you know, a little Python script that just manipulates those CSV fields into that 5-field TLN format. So after all these artifacts have been parsed, two final steps that kind of need to be done on them. So Eric's tool kind of works as this framework. So any tools that you have that kind of output to the screen kind of get funneled through Kabe and then get put into an output file that's designated in the module. Well, when that happens, Eric has written his code with Unicode capabilities. So the file actually comes out as Unicode. In my testing, parse.exe did not seem to support the Unicode. I may be wrong there, but that's what it looked like to me was occurring. So I just wrote a quick little utility that will convert the Unicode back into ASCII so that I can use Harlan's parse.exe. What parse.exe does is, as I mentioned before, the TLN format has an epoch or an epoch timestamp. Well, as an examiner, that's not very intuitive to look at, right? Maybe we can tell by the first 3 or 4 digits in that epoch code what year it is. But, you know, as far as getting down to converting it like manually in my head, that's just not going to happen. So parse.exe is going to take that epoch timestamp, it's going to convert it into a human readable format, and it will also sort it with the most recent activity at the top and the oldest activity at the end of the TLN file. So, all right, kind of went through all that. I was just giving you a peek behind the curtains, but really running the tool and doing all of this happens very seamlessly in the background with Kabe. So earlier we had created our target and our triage collection. So now we want to run the timeline modules over that data that we collected. So if I just filter by timeline, you can see here there are 2, these are the 2 that I've written, the mini timeline and the mini timeline sliced by date range. You can see here that someone has also done something with Plazo. Looks like a Plazo end-to-end test. So these are my 2 modules that I've created for this mini timeline and to create the mini timeline. For my modules, they will require a computer name, right? Because we mentioned one of the TLN fields was a computer name. So the cool thing about Kabe is that you can actually pass it variables in the command line, and also, you can leverage the GUI to build that out. So right here in this key, I can simply add in my variable computer name. And for this one, I'm just going to use my name as a computer name, and I can add it right there. I have added in the description. This is so cool. Eric has taken so much time and effort into this. If I hover over the description, I've added into the description, you can see it says right in there to add in a key computer name. So after this presentation, if you're running the tool and you can't remember what the variable is that you're supposed to add, you can hover over it and get it right there. The next one I have is the mini timeline slice by date range. So if you're dealing with a computer that's been functional for 10 years, do you really need a full timeline that goes back 10 years? Probably not. You're probably going to be looking at the most recent activity on that system. So that might be a year, that might be the last 3 months, whatever is going to make the most sense for your case. So if you want to do the slice by date range, you can select this module, and then you would just add in your key and value right here. And once again, I've added a little note here that tells you to add in a variable with date range, and then what the format needs to be, which is the month, day, year, hyphen, just like that. And this is, because it's a command line tool, you do need to have, like the leading 0 in front of your shorter months. It's going to be looking for that. So this needs to be very specifically this format. If it's not, that is probably going to be an empty file when you get it. As you can see here, as I was choosing my options, it was once again building out the command line options as it went. So now, since I've already done the collection, I'm going to uncheck this, and I'm just going to go ahead and use the module options. So for my module source, I'm going to browse to where the output files were created. So that would be my Kabe and then the Triage collection. Those were the files that I showed you earlier, the MFT, the EVT, and the registry hives. Okay, and then my destination is where I'm going to be dumping out that data. So here I've got it under Kabe and Triage collection. I'm going to put it in a timelines directory right there. All right, so it's going to run through these. Now, if I double click on this, if you want to see everything that's being called, you can just double click on this and get an idea of exactly what this is doing in all the modules that it's calling. So right here, I've got the body file. I'm converting it to TLN format. You can see it's going through the event logs. If it's EVT, EVTX right here, RegRipper is being run over the registry hives into TLN format, right there. And then right here is where I'm using some of those TLNs right there in the TLN format. And then here at the very end is where I'm kind of doing the conversion. After this timeline has been built out, I'm converting it from Unicode into ASCII, and then I'm running that final tool over it. So pretty straightforward as that goes. And then I just click execute and off to the races. Once again, it's letting me know that flush options are enabled. That's okay. And it's going to go ahead and run through. Now, Eric Zimmerman has done a great job, once again, of showing very verbose information as it's processing this. So you can see exactly what's happening. And he also has it all writing out to a file. So if you're not able to read that fast, that's fine, because it will all be output to see if there were any errors running it. So now you can see it just took about 25 seconds to create that timeline, which is absolutely fantastic when you think about all the artifacts that were created and parsed and gone through. So let's go in and take a look at what the outputs look like. So right here at the top, I've had the output put a 0, 1 in front of it, so it kind of bubbles up to the top. So this is our main timeline that we're going to take a look at and that we're going to examine. And then here is the timeline that is split out by the date range. these are just some of the working files that were created during the process. There's the body file, the temporary timeline. So what happens is, as each of those tools run, it's going to append onto this. So we have the registry, you can see the files, the event logs, you can see the epoch timestamps. Of course, this is not easy for us, for examiners, to look at and to read. So these are just the temporary files. You can always go and delete these afterwards if you don't need them. I might tend to keep everything, so I just leave them there. And that's what that looks like. Okay, so what do we do with this timeline once we have it? Typically, you are just not going to open up a timeline and start scrolling through it and be like, okay, let me see what I can find, right? Windows does a lot of things. As soon as you log in, it's modifying files, it's updating registry keys, it's making event log entries. So you're just not going to start looking through this. Normally, you will have a pivot point that you're working off of. So typically in cases that we have come through, maybe at the client, they contact us, they're like, hey, one of our users was sitting at their desk working. They came back from lunch and they saw the cursor moving around, and they weren't working on their computer. So now you have a date and you have a time, they came back from lunch. So you might go into your timeline and start looking around that date and around that time. Maybe they had an AV alert that triggered. So you could go in and look for the event ID associated with the application, like semantic AV alert. So maybe that's your pivot point. Maybe you're working a case where you already have your IOCs and you know, hey, when this malware executes, I know it's going to create a prefetch file, and I know that it's going to make an entry in the shim cache. So I know that I can use those at pivot points within my timeline. So for this particular example, the pivot point I'm going to use is PsExec. If you're not familiar with PsExec, it is a tool that can be used both by administrators and attackers to basically push out programs remotely to other systems. So when I start working in engagement, I may ask a client, hey, is PsExec something that your administrative people tend to use within the environment when they're doing administrative work? And if they come back and they say like, no, that's not something that we use, then I know like, okay, hey, in my timelines, this might be a good place for me to go in and to start diving into my timeline and to start leveraging and using that as a pivot point within my investigation. I love using Notepad++. I know Eric's probably rolling his eyes right now because he doesn't like it, but I like it. It's a great program. I've been using it for years. It does have one disadvantage in that if the timelines start getting really big, it won't load them in because it runs into memory errors, and that's where you'll want to use something like EditPad Pro. Because this is a CSV file, you can also load it up into Excel and use Excel to sort and filter and do all those really cool things that we use Excel for. So right here, I've searched for PsExec within my timeline, and my search results come here on the bottom. So right here, I can see that there was this program execution, and that's registry. I can also see there's some event log entries, and they're all occurring around the same time. So now to kind of dive into my timeline and take a look at that, I can double click on this entry, and that's going to pop me up into my timeline. And now this is where the fun begins. This is where I can say, okay, PsExec executed. Now, because this is a shim cache entry, the timestamp associated with this, and you can see right here, is a modified timestamp. So that's not necessarily when the file was executed, but I can see by looking at the other artifacts around the same time that in all likelihood that is going to be around the same time because I also have a prefetch file. So now I can start going, okay, I can see that there's this PsExec. What happened after PsExec? Well, right here I have a successful login because I've done this timelining process and I have the event log entry right there. I can see that there was a successful login from this remote host. Okay, so now I'm like, all right, well, if they say that they're not using PS exec and I have a login, from this remote system, that's kind of suspicious, right? So my flags start going off. So I kind of start moving up in my timeline, taking a look to see what else happened. Okay, so here's my prefetch file for PS exec, which kind of demonstrates once again that PS exec executed. And then I have another file around the same time frame called install.exe. Okay, so this is getting interesting. I can see that PS exec ran. I have a prefetch file for a file called install.exe, and I go up the timeline, and immediately after that, I have this file created called MS WinHost. Okay, so the thing as an examiner that sticks out to me about this executable is that it's in an app data location. Now, with Adobe, I would expect that files associated with Adobe would be running out of like the programs folder. So really quickly, if I kind of want to start pivoting around this and figuring out what's going on, I can be like, okay, what's this Adobe Flash Player? Maybe this is an admin, they've logged in, they're updating the system. Like, I get it. I talk to clients, they don't always know, like, maybe Susie loves using PS exec while the rest of the IT staff don't use it. So, it's possible this could be an administrator actually logging in and doing something. So once again, I could just search through the timeline really quick. Okay, let me see what I can find out about this Adobe Flash Player. And what I can see here is that I'm not really seeing a programs directory for the Adobe Flash Player. If something called Adobe Flash Player had been installed legitimately on a system, I would expect to see a lot more hits than this. I would expect to see something in program data. There's got to be registry entries. They probably update the software, but here I'm really only seeing a little bit of activity. So immediately, I think that this MS WinHost is probably some type of malware or some kind of file that's not supposed to be on the system. So I keep on going up a little bit further, and boom, right here I can see that there's an entry for a run key that was made in the registry. So already within a matter of minutes, it took maybe 30 seconds to collect the triage data, another 30 seconds to generate the timeline. Now this is like best case scenario. I've got an image here that's relatively small, so you might be looking a little bit more time, but I've already established who was logged into the computer, a couple of files that executed that were suspicious, and a persistent mechanism. Now, at this point in time, when you're kind of doing this triage approach, you don't just have to do triage. Now I can go back to the disk image and I can pull that MS WinHost file. I can get the hash for it. I can run it through a sandbox. I could pass it on up through the person that does my malware reverse engineering. I can go in and I can browse to and use Registry Explorer to go see what is in that run key. If I come across an event log entry that I'm not familiar with, I can go Google it. Google is my best friend. I can go to Google and I can say, hey, what is this event log entry that I'm seeing around the same time frame? What's going on around this that I may not know as examiner, and I might have to dive in and figure out what's happening. So that's how you can kind of leverage those timelines to find those connections, build out those connections, and once again, can consolidate all of that information into one format. Now, all I really have to do is every time I see a line like this that's interesting, I can copy and paste it into a new file and kind of build out the things that I find are interesting. And now I have a nice CSV file with 5 fields. I can bring that into Excel, maybe pare down some of these things a little bit, but now it's just so much easier when it comes to reporting and it comes to the note-taking on what I need to look at and share with my client and maybe other examiners within the practice. So real quickly, how to make your own TLN module. Honestly, you can just go in and copy one of the existing modules that are in there that have already been created. You can just go into the modules. Timelining is where I have all of my timelining ones. And let's say there's, you have a favorite Reg Ripper plugin that you really want to use. You can just go in here and change this plugin field. You'll also want to change the GUID that's assigned to each one of these modules. So each module has its own GUID. That way, Kabe knows what it's already ran and hasn't ran. So you'll want to change that. Eric, bless his heart, put in this append flag for me, of course, in like 5 minutes after I asked for it, because he's quick like that. But the situation I was running into is we have this temporary timeline that we're building out. And as you build out the timeline, you keep on appending to it, appending to it, appending to it. The first time I ran Kabe, before it had this append flag, I had like 20 of these files that I had to go and then run another script over at the end to kind of consolidate them all into one timeline. But now that there's this append flag in Kabe, I can append as I go to every single one of these files to kind of build up that timeline. Once again, Eric has written up great documentation on how to do this, but honestly, if you just want to get up and running really quick, just take a look at some of these modules that have already been written. They're in the YAML language, like yet another markup language, so they're pretty straightforward. Once you have created your module, you will want to add it into that parent module that calls it. So looking in here, that would be underneath the modules where all the parent modules is. You would just open up the mini timeline and add in, copy, paste one of these lines, then update whatever the name is of your particular module that you created. So what's really cool about this is if you're working a case and you know where all of your IOCs are at, they're in the shim cache, they're in my prefetch files, and they're this event log entry, you can leverage Kabe and really tailor it just for what you need. You can write a module that just calls those 3 or 4 things, and you don't have to process everything else. The nice thing is if you have multiple examiners working a case, you can share these modules fairly easily and just be like, hey, everybody that's working this case, click this target, click this module, run it. And then you have consistency across your entire case. We just had a really large case at Kroll where we were able to leverage this. We had, I want to say, like 20 people out in the field conducting examinations. So we were able to just supply the target and the modules, and everybody was consistently grabbing the same data. This could also be shared with clients. If they're trying to cut down on the travel costs, you can have them leverage something like Kabe, and you can send the modules to them. You can send it and have them, you can go, okay, click this, boom, you're done. And then they collected exactly the data that you need to be collected. So I'm going to take a pause here. I know that we had a lot of questions earlier that went through a lot of material. So Carol, I will go ahead and turn it over to you and see what kind of questions we have.
All right, yeah, we do have quite a few, so I'll just jump in and get started. Is it possible to collect the, and if you've answered it throughout, I haven't really gotten any word that you've already answered it, but if you attended to it, we'll move on. Is it possible to collect the data by Kabe to generate timeline?
Yes, so I'm not sure I understand the question, but in order to generate timelines, if you have other tools that you're using to generate timelines, you could absolutely use Kabe just to do the collection and use whatever process on your back end to generate your own timelines. You would just need to modify your script, depending on how you've collected that triage data with Kabe. So I hope that answers that question.
All right, thank you. I have tried to use Kabe and got an error on binaries missing for various modules I select. Is there a way to do a batch pull to get the binaries needed for the modules that have missing binaries?
Yes, there, but I don't know it. It's in the documentation, and I could probably tweet that out later, but there is a way that you can call Kabe through the command line, and it will list out what binaries are missing, and then it will also tell you where you need to go get them. So for instance, in each of the modules, it will actually list where the binary URL is. So I want to say there's like 100 different modules. Kabe will actually go through and it will list out for you which binaries are missing. And then when it lists out that information, it's going to list out the binary URL. And I don't know if Eric Zimmerman is on this webcast or not, but that's absolutely something that can be done. And I can tweet that out later on how to do that.
All right, thank you. Is it best used for live analysis or also offline usage on disk images?
Both. And it probably just depends on your process flow and what works the best for you. So I've had people tell me that they will attach, so like if you're out in the field and you're using dead box, or you're taking a dead box image, you might pull the drive, do your triage data dump, and then, start taking your image. So that's kind of like the dead box approach. Now with a live system, you can actually leverage Kabe to call things like the sysinternal tools. You can get running processes. You can get, you can run auto runs. So you can run Kabe from an external drive on a live system, pull back the triage data, and then for that destination, you would just choose to dump it out to the hard drive rather than the computer that you're doing the live examination on. Once you collect that data, I would recommend that you run the modules on a different system, because the last thing you want to do is be on a system that you're analyzing, run a bunch of modules, then of course that's going to make all those entries on the system that you're analyzing live. It's going to change the jump list on there and the executable. So once you collect the data from a live system, you can then take that data onto your analysis system and take a look at it there. Next question.
Yeah, okay. Would something like F-Secure to get a remote connection to pull from a host, correct? I think maybe this is referencing, I think this is from the batch of questions from earlier.
Oh, okay, like SFTP. I have not personally done something like this and executed it against a remote. I'm not going to be able to provide that much visibility into that, but I know Eric is adding some new capabilities into it with like SFTP, so that might be a good topic moving forward on how to utilize it doing a remote collection, but I'm unfortunately not able to answer that question at this point in time.
All right, thanks. I can see McAfee log options. Are you guys planning to add more AV vendor logs?
So that is entirely up to the community. That's one of the great things about Eric's program, is that it's really a framework for modules. And as people find things in their investigations and they're doing things in their processes, they can contribute modules. So if someone has McAfee event logs and someone's written a parse for or utility, that is something that can absolutely be added in. And I know, Eric would be more than happy to assist. Totally throw him underneath the bus there. Myself, I would be happy to assist. If you have a program that will parse out the log files and you can give us an example log to work with, we can work on building out the module for something like that.
All right, thanks. Can Kabe collect these artifacts remotely, or does Kabe have to be copied onto the targeted system to be run?
So you could do something like map a network drive and have it on a map network drive. I guess that's kind of like a remote way to do it. Kind of talked earlier about using a tool like F-Response, and I think I kind of answered that earlier. Kabe does not have to be installed on the system per se. Everything within Kabe is contained within one folder. So much like SDK Image or Lite, you can just copy this Kabe to your external drive. So all you need is the Kabe tools, the modules, and the targets that can go kind of on your incident response external USB drive, if you will, and you can execute everything from an external drive against a live system.
All right, thanks. Is the minute timeline collection tool available somewhere?
Yes. So let me pull up the slide. So right here, to download Kabe, go to this URL, learndeafandself.com, Kabe. You'll be emailed a link to download Kabe. The GitHub is right here. That's where the latest modules and targets will be. Like, for instance, Eric just pulled in my changes today for all those timeline modules. And the cool thing is Eric built right in here sync with GitHub. So if you already have Kabe and you want this timeline capability, you can do a sync with GitHub and you will pull down now the 20 or so modules that I wrote to do the mini timeline, as well as any additional features or modules that have been pushed out from the community since you've gotten your version of Kabe.
All right, so it sounds like you just answered the next one that said, will you share the module you wrote? So nice job. Does Kabe support .etl files?
ETL files. Off the top of my head, I'm not sure. Are those the transaction log files? Maybe if that person can give me a little bit more information on the ETL files. Kabe in and of itself doesn't support like that. It's the modules that support it. So you would tell Kabe to copy those type of files, and then a module would have to be written that will parse them out. So, whatever the ETL file is that you're referring to, if you have a command line tool that will parse it or that works with it, then yes, it would support it in that fashion.
All right, we're over time. Do you have another minute or two, or are you?
I'm fine. I could keep answering questions. Yeah.
Okay. Someone says, can't we use Timeline Explorer from Eric Zimmerman?
Eric, did you post that question? Yes, you can use Timeline
No, he did
Explorer.
not. He's not the asker.
Yes, you can. Yes, Timeline Explorer by Eric Zimmerman will open up CSV files, and that is a CSV file. Me personally, I have not used Timeline Explorer to open it up. I just tend to work with Notepad++, but it's a CSV file, so you should be able to use Timeline Explorer to open up the timeline file, which is a CSV file.
All right, thanks. Do we need to add tools into a directory within the Kabe folder structure for it to call upon?
Correct. Right here where you have the modules, let me pull this up. Okay, so right here within Kabe, you have the modules and there's the bin. So this is where you would add in any binaries that you want or that are being called by the module. So for example, I'll go into one of my timelining ones. I wrote the utility to convert the Unicode to ASCII. So if you look at it right here, it's going to tell you, okay, this is where you go download it, and then it will go into the main binary folder right here, and that's where it will be called. Now you can see some people kind of broke them out. So RegRipper has its own folder. So if you go in and you look at a module that is written for RegRipper, it will actually give you directions on where you need to put that. Let me see if I can find an example here. So right here, they put in a comment, place rip.exe in this DLL in this folder and the modules bin RegRipper.
All right, thank you. We'll take these last two, and then we'll have to move on with our day, I think. But can you add other event logs like the Sysmon event log?
Absolutely. So in the collection that's being done now with, go back over the target modules. So let's see if I can do this. EVT, or we'll just look for event logs. So here is the targets, and that's where you describe where you want your event logs captured. So you can see here, this is going to capture everything for EVTX. So if you're running Sysmon on a live system, you can include that as part of your target module. If it's EVTX, you would just specify it should be captured by this because there's just a file mask working. So if it has a .evtx extension, it should catch it. If it doesn't, you could just manually add it into one of these targets and specify whatever path it's in and collect it at that point in time.
All right, last one. Is Kabe Windows only, or is there a Linux version?
So Kabe is Windows only. I don't want to say there are a lot of downsides about Kabe because it's absolutely a fantastic program. But yes, it is Windows, and it is based off of .NET, I want to say 4.6. So the .NET library does need to be installed. I believe moving forward, there might be a wrapper that might be provided with Kabe that will allow it to run on systems that don't have the appropriate .NET version, but most modern systems of Windows should have that. But no, there is not a Linux or a Mac version of it.